guys, welcome to another video clip of MrLopezClasses.com. Today is a special video. We are going to analyze the silver chloride electrode. This is a special tool used to check the reference voltage of my boat, the structure of my boat, with respect to the water, with respect to the ground. Depending of that range of voltage, we are going to analyze if the boat is properly protected, a little overprotected, or underprotected. Yeah, depend of the material of the hull, the type of water, and the condition of the bonding system in your boat. Until today, it's clear that the only way to protect my boat against corrosion is if you keep the boat dry and clean. This is the number one. Number two is bonded all the metallic elements inside of the boat to the bonding system and connect the bonding system with the external sacrificial anodes. What type of anodes? Depend, like we analyzed in previous episodes, depend on the material of the hull, depend on the type of water and other external factors. Okay? If the boat is properly connected, the boat internally is dry and clean, you eliminate all the sources of leaks internally in the boat, probably your boat will be properly protected. And now we are going to use this tool. The silver chloride electrode is a special tool used for surveyors, for inspectors, for marine engineers, for boat owners, in order to verify if your boat is properly protected. If all the systems that you have in your boat, included the galvanic isolator, are working properly. The silver chloride electrode is simple, depending once again of the material of the hull, and we are going to analyze today a special boat. It's a European boat, Azimuth. It's 105 feet long. It's an inboard boat, two Detroit diesels, MTUs. Wonderful engines, wonderful boat. We check with the silver chloride electrode the system. The boat was recently serviced. They replaced the sacrificial anodes, and they fixed the bonding system because a lot of elements were disconnected from the bonding system. Right now everything is properly connected. Okay, we are going to check that boat. We are going to analyze with the silver chloride electrode. We are going to try to understand how the silver chloride electrode works, what is the meaning of the silver chloride electrode, and how will be connected to the meter, and how will be connected to the boat in order to verify the condition. We need the silver chloride electrode. Probably you need an extension of 25 feet, 15 feet of wire number 12 with alligator terminals in both ends. You need the multimeter. We are going to use the multimeter on the scale of DC volts, and that's it. That's the only that you need. And we are going to check what is the meaning of that system. The electrode, the reference electrode, is also called half cell electrode because it's a combination of metal and metal compound. The most common is copper sulfate, and silver chloride. The secret is as soon as you finish the procedure, flush the electrode with fresh water and keep in a sealed bag the silver chloride electrode. The first step is disconnect the sources of power. All the AC and DC breakers off, and it is possible disconnect short power and verify that you don't have any input of current, AC or DC current. That's the number one. Don't forget. Check the short power, disconnect the short power, and all the switches, AC and DC, battery switches, breakers in off. Introduce the electrode into the water. Yeah, that's the number one. In this particular boat, we use two measurements. One measurement in the engine room in order to check the bonding and the blocks of the engine, the motor mounts, and other measurement outside on the anchor. We check if the motor is properly bonded if the chain is properly bonded, we found that the chain is improperly bonded, not connected. It's simple, connect to the bonding system. We found that the reading on the chain was out of the range. For that reason, we introduced the electrode in two different places. The first place where we introduced the silver chloride electrode was on close to the engine room in the crew cabin. They have a circular window close to the engine room. We introduced the silver chloride electrode in that area. Yeah, you see, the silver chloride electrode is touching the water, and right now is entering in the water no more than 3 feet. And after that, the cable of the silver chloride electrode is extended with the blue cable, and now is connected in the negative side of the multimeter. Okay, this is the first step. We did that connection in front, and in order to check the condition of the engine room, and also we did other measurement in front where the windlass is located, and also over there we introduced the electrode on the water. Exactly, and now the other end of the cable was connected into the negative terminal of the multimeter. Okay, this is the number one. Introduce the electrode in the water and connect in the negative terminal of the multimeter. And the next step is connect the electrode cable into the negative, and the positive depends. If the boat is in fiberglass, connect the positive terminal of the multimeter to the block or to the element that you want to measure. But if the boat is in a metallic boat, in aluminum or steel boat, the positive terminal of the multimeter should be touching any part of the structure over the water line. All right, that's very important. And now we are going to set the multimeter in the scale DC, and we are going to read millivolts. No? Don't forget, remember that minus 500 millivolts is bigger than minus 1000 millivolts. Minus 1000 millivolts is minus 0.001 volts. No? And exactly, minus 1500 millivolts is more negative than minus 500, because it is in this area of the negative scale. All right. If the measurement is more negative, the potential difference will be bigger and will be better. Depend of the range. Right now we are going to analyze that situation. And okay, this is the range of measurements. We are going to check for fiberglass boat with inboard engines. If the reading is in between minus 750 to minus 1000 is appropriate. This is a good range. This is a good range. In our particular example, the reading was minus 600, minus 500 and something.
Today we are going to use the silver chloride electrode. The silver chloride electrode is a reference voltage, and we are going to check with the silver chloride electrode introduced in the water, the cable connected to the negative of the multimeter, and the positive of the multimeter, the silver chloride to the negative, and the positive will be connected to the bonding, or to the block of the engine, or through the anchor. The metal that you want to check the voltage reference, according with the table that we have on the screen, yes, for fiberglass hulls, this is the voltage reference recommended. For aluminum boats, for wood, those are the measures recommended. In this moment, we are in an azimuth, 105 feet in fiberglass, and we are going to check the reference. We are going to introduce the reference electrode, silver chloride electrode, in the water, and with the multimeter, we are going to select the volts DC, and we are going to check what is the voltage and we are going to verify if the voltage is according with the measure recommended for fiberglass hulls. Okay, the electrode, the wire of the electrode is connected to the negative terminal on the multimeter selected on a DC. And the positive terminal will be touching the element that we check the reference. In this particular case, we are going to touch 1 volt in the motor mounts. 1 volt, I remove the paint, and we are going to check minus 0.600, minus 0.602. We are going to check other part of the block. For example, in the raw water pump, the elbow of the raw water pump, minus 0.440. We can touch the element through holes, fittings, blocks of generators, and we verify if the voltage is on the range. Once again, we are going to check the motor mount of the starboard engine. Minus 0.600, 599. Don't forget, the electrode, the silver chloride electrode is connected to the negative of the multimeter, and the positive LED will be touching the element that you want to check the voltage reference.
In our particular example, our boat, the reading was around minus 600 millivolts. This is the situation. This is 0. This is the positive range, and this is the negative range. This is minus 500. This is minus 1000. This is minus 750. And our boat is located here, is minus 600. The range recommended for this type of boat is here, in between minus 700 and minus 1000. This boat is minus 600. That boat needs a little more protection, probably more sinks, a little more amount of sinks, because in this particular case the boat was recently serviced. They replaced the sacrificial anodes. In my opinion, in this boat should be installed extra sacrificial anodes. This particular case is a fiberglass boat. This boat works in brackish water and salt water. The zinc anodes are recommended in this particular case, but probably a bigger sacrificial anode than the actual anodes. Yeah, for that reason, that small gap in between minus 750 and 600, we need to move it a little more negative. We need more anodes. We need more anodic protection. Okay, this is in this particular case the situation in this boat. We are going to continue. We are going to check the other possibilities. If the boat is in fiberglass with outdrive, the reading should be in between minus 900 and minus 1050 millivolts. If the boat is in aluminum, the reading should be in between minus 900 and minus 1100. This is the reading for steel boats, and this is the reading for wood boats. Okay, this is the reading for wood boats. And now we are going to check in front of the boat the windlass, the condition of the windlass, and we found that the chain is not connected.
Now we are going to introduce the silver chloride electrode. We are going to verify the condition of the windlass, the condition of the anchor, the condition of the chain, because we have suspicions that the chain is not connected to the bonding. We are going to verify the reference voltage in between the chain and the electrode, and the reference voltage of the anchor, the motor, with the electrode.
Remember that if you are an engineer, if you are an inspector, if you are a surveyor, you need to demonstrate to the customer where is the problem. In this particular case, we have a minus 600 millivolts. And the recommendation for that boat, fiberglass boat with inboard engines, is in between minus 750 and minus 1000. We are pretty close, but we need more protection. But we need to demonstrate to the customer that the boat needs more protection. Normally I use this element. This is the grouper anode. It's an anode of a zinc, like a fish anode or grouper anode. I introduce the anode in the water and the other end with the alligator connected to the bonding conductor inside of the boat. For that reason, I use this longer cable, or I extend with more wire. I connect to the bonding internally, and this one suspended in the water. And I take the measurement again, and I demonstrate right now pass from minus 600 into minus 850. Right now is in the range. This is a demonstration that the boat needs more protection. The other way is when the boat have extra protection, when the boat have overprotection. In that particular case, it's not good. Overprotection, delaminate the paint on the hull, produce like bubbles on the structure. For overprotection, is not good. Normally, it's recommended keep the boat in the range according with the material of the hull. Okay, guys, this is the situation, and don't forget, at the end, when you finish, you need to flush the electrode, flush the silver chloride electrode, clean the electrode, and introduce the electrode in a plastic bag completely dry. I recommend try to keep in your tools the silver chloride electrode, a good multimeter in order to verify the condition, the potential difference of your boat.